If f of x is equal to negative x squared, determine f prime x by using first principles. Right, so we know that to get f prime x, we are going to have the limit as h approaches 0 of f of x plus h minus f of x all divided by h. We are going to substitute f of x plus h and f of x. This is going to be the same as lim h approaches 0. F of x plus h, we have negative x squared there. This means that inside the x squared that we used to have, we're going to have x plus h. So we are going to have x plus h squared minus x squared divided by h. We are going to expand. So lim h approaches 0. Let's keep the minus outside for now. So this is going to be x squared 2xh plus h squared. This is going to be plus x squared and divide that by h. So this is again lim h approaches 0, negative x squared, negative 2xh, negative h squared plus x squared divided by h. X squared and x squared cancel out. This means we are left with minus 2xh minus h squared. So this is going to be the same as lim h approaches 0, factoring out of h because we're trying to cancel out the h at the denominator. So this is minus 2x minus h divided by h. So to remove the lim, we're just going to substitute 0 where there is h, and this is just going to be negative 2x minus 0, which is the same as negative 2x. So this is our f prime x. 9.2.1 says determine f prime if you have x squared minus 9, x minus 3. So 9.21, f of x is equal to x squared minus 9, x minus 3. Because in grade 12, you don't do quotient rules. So what we're going to do is just try to simplify this. So what we can do to simplify is to see that this is a difference of two squares. So this is the same as x minus 3, x plus 3 divided by x minus 3. And then cancel out x minus 3, we're left with x plus 3. So to find f prime, we're just going to differentiate x because this is a constant, because 3 is a constant. So this means f prime x is just 1. 9.2.2, we have f of x being equal to the root of x plus 1 over x all squared. Another thing is try to simplify your equation. In this case, we have root of x and we have everything being powered like that. So to simplify this, you can rewrite root of x as x to the power of 1 over 2. And you can expand this so that you have x squared plus 2x 1 over x plus, look at what's happening. This is 1 over x, which is the same as x to the power of negative 1. So x to the power of negative 1 squared is the same as x to the power of negative 2. X and x will go, and here we'll be left with 2. This is the same as x to the power of half times x to the power of 2. This is the same as 2 plus 1 over 2. That is 5 over 2. The 2 multiplied by x to the power of 1 over 2 plus x to the power of negative 2 plus 1 over 2. This is negative 2 plus 1 over 2, which is the same as x to the power of negative 3 over 2. Right, so to find the derivative of this, we're just going to perform a power rule. So that's 5 over 2x, 5 over 2 minus 1. 5 over 2 minus 1 is 3 over 2 plus 1 over 2 times 2, that's 1. So if you just have x, 1 over 2 minus 1, that's minus 1 over 2. Minus, because the negative 3 over 2 will come and multiply this side. So minus 3 over 2x, minus 3 over 2 minus 1, that is negative 5 over 2. So if you want, you can just leave it here. It doesn't really matter. But if you really like neat stuff, so you can just continue and say 5 over 2, x 3 over 2 plus 1 over x to the power of 1 over 2, which is the same as square root of x, minus 3 2x to the power of 5 over 2. So you can leave it here, or you can continue if you still have time.